Hello, calculus fans. Okay, now we're going to talk about a comparison theorem for improper integrals. So the idea is that sometimes we can't actually compute the exact value of an improper integral. And yet, it can be useful to determine if the integral converges or diverges. So we have a theorem for this. This is called the comparison theorem. So let's suppose that we have a function f of x that's bigger than g of x, and g of x is bigger than 0. So everything's positive, at least for x bigger than a. And the first part of the theorem says that if the integral from a to infinity of f of x dx is convergent, then the integral from a to infinity of g of x is also convergent. So g of x is a smaller function than f of x, and so if f of x, the integral of that converges, then the integral of g of x converges. The contrapositive of this statement is that if the integral of g of x is divergent, then f of x, which is bigger, a bigger function, that has to be a divergent integral. And it's not all that hard to make a similar statement, a similar comparison theorem for improper integrals with discontinuous integrands, the second type of improper integrals that we were dealing with. Okay, so we'll go over an example in a moment of how to deal with the comparison theorem, how it's used. Okay, that's all for now.